Hello and welcome to week 2 of the Maths online course from Coventry City Council. My name's Debbie and I'm your adult education tutor. Hope you enjoyed the week 1 resources. Apologies for the delay with some of it. The new technology has been somewhat baffling at times, but I'm hopeful that that's now ironed out and things should move forward very easily. So welcome. Okay, so we are in week 2. Here is our telephone number should you need to call the service for any information about the courses, etc. Just to remind you that we promote both the safeguarding and prevent agenda to protect vulnerable people in Coventry, and we have a safeguarding obligation to you as individuals. Just a reminder of the British values and rules for life, again, which we promote and are promoted in the schools in the area as well. So in this session, here are the objectives. We should be completing the work and place value. We'll begin to understand addition, and we'll look at some of the curriculum expectations around that. We will begin some written formal addition processes, look at some more vocabulary and some activities and games to play, including some resources that children will quite like to see in school. Just to make you aware within this, we are looking in our face-to-face sessions at a new diary, which is where we look at how people have built on their knowledge week by week. And we're looking at a traffic light system. So where would you put yourself at the moment with regards to addition? Do you think green, I understand it already, I'm really hot on addition, I know how I'm going to help my child with this. Red, no ideas at all. Or do you come somewhere in between? And just have a think for your own benefit where you stand at the start of the session. And hopefully by the end of the next 2 sessions, because addition runs over 2 weeks, you will be feeling a bit more confident. It'd be interesting to see for your own benefit, really. Just to remind you about these task images again, you see the thought bubble, have a think, notepad, jot it down for yourself, listening and to repeat out loud. So just some more information about the course in general. It's approximately 45 minutes long, the videos. This is week 2 of 5. And if you need to take a break, there is a spot where I sort of suggest it's a good place, but if you need to answer the door, deal with your children, whatever's going on, feel free to pause as we go. And we always like to do a little bit of a recap, just obviously a week's a long time between looking at these sessions, or longer obviously if they're recorded, so it's just to make sure you can remember what we were looking at last time. So last time we thought a lot about counting, literally what counting is and how we do it and when we do it, or the opportunities with rhyming and counting things with our children at home. Thinking about numbers as actual things, thinking about their position and value, particularly with regards to place value. And number bonds, the real importance of those, especially to 10, which helps us to in our hundreds, in our thousands, and also in our decimals as well. And some of the resources that we looked at. So last week we focused quite a bit on place value and we had a look at it. Do you remember this sort of layout? We talked about we've got a H column, a T column, and an O column. Can you remember what each column is for? What's the H for? What's that first number in the H column? So we've got a 3 at the top. H for hundreds, yeah. So we've got 300 in that column. The middle column, the T, is for tens. And the last column with the O at the top is for the ones. Used to be units, we now call it ones. So looking straight across the top then, we've got 3 hundreds, 6 tens, and 1 1. What number does that give us? 361? Yeah. Next one down, sorry, we've got 500s, 0 tens, and 8 ones. Bit trickier because there's a 0 in that tens column, but what number have we got? 508. No tens, so we just go from the hundreds to the ones. Okay. And the bottom one, 300s, 7 tens, and 0 ones. Gives us 370. Okay. Just to run through that again. Now, one of the resources that you did have sent out to you was these place value cards. They come in the pictures show you the number of different ways that they come. You can get them in all sorts of different ways. Generally, they're colour coded. And there's a lot of activities you can do with them. Schools will have them. Your children will probably play with them. So I'm just going to show you a couple of little activities. So generally, each set of cards is coloured differently. So for instance, this I'm showing you here, my hundreds are in green. My tens are in pink. And my ones are in orange. Okay. Different systems have different colours. Okay, so you can build with these. Okay, I've made my 100 tens and ones column, and I've just done it on a whiteboard. You could do it on paper. It's up to you how you do it. You might print a set of these cards off and do it yourself. I just wanted to show you some other ways. So I've got my 200s, the 2 in the hundreds column, 0 in the tens, 0 in the ones. Okay. Now I'm going to put my 50 on. Okay, so 200. I'm going to stick over the top. So now, what's my number now? We've got 200s and 5 tens, yeah? At the moment, my number is 250. And I'm going to put my ones on. This time I've got 7 ones. So again, sticking it over the top, I've just used blue tack for this. I've now got myself a different number again. So this time I've got 200s, 5 tens and 7 ones. And what number does that make? 250. Now, looking at the other side of the board, we can start to take that apart as well. So sometimes children might be asked to build a number. Sometimes the activity might be to take the numbers apart. So what's my number? 948. Super. Okay, so looking at that, how many tens have I got? I've got 4 tens. Okay. What's 4 tens worth? 4? Is 4 tens worth 4? No, it's worth. Let's check. Let's take our unit out. One's off. It's worth 40. Okay. And literally by pulling the numbers apart, you can get the children to see what 948 is made of. Yeah, 900s, 4 tens, which is 40, and 8 ones. There's lots of nice things that you can do with that, just pulling the numbers apart and sticking them together. And you don't need a lot of resources to do it. Have a go. The kids love it. And it's actually a really good way of them building numbers. Okay, you can tell me it's 40, but actually if I can see it's 40 because it's there, even when I make 48, for instance, my 40 is still there. I can still uncover it. I can still see that it's there. That's really useful for children to keep it in mind by being able to physically touch it, feel it, and see it. Have a go with those if you get the chance. Okay then, moving on to addition. What vocabulary can you think of when you think of add? Okay, vocabulary is just other words. Okay, so what words do you think of when you think of add? Okay, here's a nice picture to give you some ideas. Okay, we've got, starting at the top and working around, total, more, sum, and, add, together, increase, plus. Some of these words might seem quite obvious to you and some of them might not have done, but yeah, there's lots of different ways to be thinking about addition, lots of different words that lead us to addition problems. Okay, so sum, if somebody asks you to do the sum of 6 add 3, sum. Number sentence, 4 add 7, simple add. Calculation, calculate 16 add 27. Okay, there's lots of different words, and quite often with children, because we're teaching them the language of mathematics now, it's not just a page of add sums. There'll be number sentences, so it will be, for instance, Johnny had 15 tomatoes and he dropped 7. How many does he have left? Or Mariam went to the shop to buy 20 toilet rolls and her mum saw her on the way and asked her to buy 9 more. How many did she buy altogether? Okay, it's not just 6 add 4, 7 add 3. We try and relate it to real life. We try and make children understand why they need maths and why they need to learn to do these things, because it makes them more engaged. It makes them more likely to use it. And if they're using it, it's keeping that going in their brains. So first of all, looking at the early years foundation stage, how does addition come into it? We will move on to the national curriculum. This is part of the reason why this goes over 2 weeks, because there's a lot to it. But in the early years foundation stage, so this literally is starting from children come up to the age of 2 years right through their preschool and their reception year. So at 22 to 36 months, The expectation that we're aiming towards is that children know a group of things changes in quantity when something is added or taken away. So that could simply be a bowl of fruit. You've got 4 oranges, you put 3 more in. And it might not be something they can verbalise yet, but they know that the number has changed, and that's what you work on. So children then start moving into the next, and there's an overlap in these ages deliberately, because obviously some children will start on the next group of objectives before they hit that age. So there's an overlap because some children will be in one area for bits and one area for another. So at 30 to 50 months, the expectation is they start to compare 2 groups of objects, same when they have the same number. So it might be 4 apples and 4 bananas. It might be a bowl, 4 balls and 4 circles. You know, it's beginning to see. And again, it may not be completely verbal. It might just be that they're starting to play with the objects in an adult-led manner as well. At 40 to 60 plus months, so this tends to be in your preschool, nursery stages. It moves up again, and we're asking children to use the language of more, which is obviously add, to compare 2 steps of objects. They're finding 1 more or 1 less from a group of objects to 5 and 10. And in practical activities and discussion, they're beginning to use vocabulary involved in adding. So we're starting to talk about, Mummy gave me 3 sweets and Nanny gave me 4 more. And it's them beginning to use that. Okay, so by the time they've finished in reception, there's actually quite an expectation on the adding, even if it's more physical than writing down. There's quite an expectation that children have got some concept and understanding. And the early learning goals, which is what all this aims towards, is that children can say which number is 1 more or 1 less than a given number. Using quantities and objects, they might be using bricks, they might actually be using, do you remember we talked about the concrete, the pictorial and the abstract last week? So they would be using things to do this. They add and subtract 2 single-digit numbers, so that's numbers from 0 to 9. And they solve problems including doubling, which does come into adding, okay? Because if we're doubling a number, it's getting bigger, isn't it? We're adding, we're going further on, okay? No pressure on this. If your child is in reception, you're thinking, oh, we've never done doubles. It's not a massive issue. It's just showing you. This just gives you some idea of the framework, okay? All children will have areas where they're a little bit more able and areas where they've perhaps got less experience or they need more support, and that's perfectly normal. A framework is just that. You know, it's a rough guide to what we're aiming at, but it does give you some idea of what the schools are looking at, you know, and your school's receptions, nursery placements are looking at doing, and maybe some places that you could help at home. And I'll bet some of this you're already doing at home anyway, without realising that it comes under 40 to 60 months of the EYFS, okay? Just to show you how it fits in. Excuse me. Just as a brief overview for those of you who might be interested, and again, if you really wanted to study this in right now, pause it and have a proper look through. But this is into year 1 and year 2 and how the guidance, the newer guidance passes across with addition and subtraction, okay? So this just gives you some more ideas of actual things that the children are expected to do both at year 1 and year 2 level. As I say, if you want to look at that in more detail now, feel free, just pause us. Okay, so add. Can you use the vocabulary of add? So can you add these 2 numbers? Add 2 and 3. Okay, quite simple. More. What is 13 more than 12? Still asking us to do an add sum, just not as obvious, is it? It's not as obvious that we need to add. We've got to think about that. What does 22 and 15 make? Okay. And words in there too, isn't it? All together. What do 45 and 13 make all together? I had 45 children in the hall and 13 children in the playground. How many did I have all together? Equals. What does 106 and 56 equal? Okay. One more. What is 64 more than 16? And the sum. What is the sum of 13 and 117? All of these words lend themselves to adding, okay? Your child might not come home and say, I did 5, add 5 today. They might say, we had to work out how many there were all together. Or what does it make if I've got 4, add 5, okay? Teachers won't just be teaching add. They'll be using other words to get children used to the language of maths in everyday life, okay? And it's good if you can do that too. Expose them to it, even if they're too young to be using it themselves, should use it as well. This is a nice activity for number bonds to 10. This reinforces that finding all the different ways to make 10, okay? And because it's an activity, kids love it. Now, mine that I've got to show you is actually cars. The little grid I've got. You can make your own grids. One on the screen, the one that you'll be sent is Teddy's, but mine's cars. Literally just lay out in the same way. And the idea with this is, so for instance, if I said to them, if I've got 7, okay, so I'm going to put 7 on one side, or let's see, how should I do that? Or 1, 2, 3, 4, 5, 6. Oh, how could I do that? Oh, I know. If I put 1, 2, 3, 4, 5, 7 on one side, how many more will I need to make 10? Okay, and these grids have all got 10 on already. So the child might be able to have a look, they might be able to have a guess. Let's see, you think 3, let's check. 1, 2, 3, you were right, well done. And obviously you can fold it in different ways. If I had 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, how many more would I need to make 10? Do you not know? Let's have a look. Okay, so it's a real physical way of, they can use it to reinforce, to check their own answers when they're trying to write it out. Remember the hands we made last week? Or you can actually just use it as a nice game, a nice activity. And as I say, you can make them with lots of different things. You'll be sent a grid out to have a go with at home. And that's a really nice physical activity. The children like to be hands-on, and you can fold it in all sorts of ways. That's a nice one to look at. 10 frames. Have you ever heard of 10 frames? It's as simple as that. A grid with 2 rows of 5 on them. Okay. Have a look at this clip, and your job is to try and see if you can count, if you know how many before the number changes. Okay. Have a look. I might have to do this the old-fashioned way. Bear with me. Oh. Oops, a daisy. Here we go, guys. Have a look at this. Can you track how many there are each time? Keep watching. Have you got blurry eyes yet? Keep watching. Can you tell how many each time? 1, 5, 7, 9, 8, 1. Keep going, see if you can keep going with it. Okay, let's turn to our PowerPoint and I'll explain a bit more. So the idea with that is when we use these 10 frames, or arrays they're sometimes called, it's about always starting in the same spot. So for instance, there we always start in the top corner, and actually over time, without having to go 1, 2, 3, 4, 5, there's 5, 1, 2, 3, your eyes begin to recognize the patterns, and children very quickly start to pick up 2 always looks like this, 5 always looks like this. And the pattern, it continued in the same way. So 2 would always be the first 2 if it was going to be 2. 3 would always be that way. It wasn't dotted all over the place. And the idea is that our brains can pick up these patterns. So let me show you some more ideas that you can use a 10 frame with, because these are actually really quite nice and they are used in school. So it is possibly a good idea or something for you to have a go at home with your resources. So let's have a look. Okay, so that just gives you an idea about this, about the use of tens and the way tens are organised. Some of the things you can do with it, takes us back to counting from last week. And it also just helps us to see it's not just about having 10 boxes, it's about that fast recall, it's about patterns, it's about being able to things like odd and even numbers, it's about doing doubles, it's about seeing the place value again, 10, 20, 30. And a 10 frame is a real simple way of doing that. Okay, so using a 10 frame, then here's an example of how you could do it. So going back to what they were just saying. So for instance, if I was saying, show me 5, add 3, and we go across for the 5s, because as they were saying, it's visually easy. You can see 5 add 3 equals 8, okay? Equally, the children can see another sum there as well, because 3 add 5 equals 8. What's in there hasn't changed, the permanence of numbers, but we begin to see the relationships, which will also help them when they come to subtraction as the next step. In the same way, show me 7 plus 4. Again, we come out of one grid because we've got more than 10, but that's fine. As I was saying, you can use another grid underneath. Okay. Now, all this links to something that a lot of schools have taken on, which is Numicon. Have you heard of Numicon? Numicon is actually not an Australian concept. That's where it was first made, and it comes in a box a little bit like this. And I'm showing you the box like this just to show you how each grid is made up of 10, all the different ways of making 10. And the way they organise it in here, I'm going to put the lid on so it doesn't all run away, so I can show you, is in 10. So straight away, it's brilliant for number bonds because each section is in 10. So here, we've got 2 red 5 pieces to make a 10. Here we've got a 10, a blue 10 piece. Here we've got a 6 and a 4 making a 10. So it's already, in the way it's organised, it shows children 10s and number bonds to 10, which is brilliant because that's, when they pick it up, it's quite systematic. In the same way, so for instance, the 9 and 1 you've got on your board there, a 9 piece and a 1 piece. Very similar to those 10 squares we've just been looking at, okay? Very, very similar in what it does, but it's actually physical equipment, which is a good thing with kids because being able to touch it and being able to feel it, experience it, play with it. The first thing your children probably will do with this in school, if they start looking at this in early years phase, is play with it. It's a bit like Lego, isn't it? I suppose, in terms of you can fit different things together. You can make different things, but you can make pictures with it. You could have a go at making a dog out of this or a fish, or quite easily. Okay. So Numicon, some schools use it, some schools don't, but it is a good way of using arrays. It's a really useful way of doing that. It's colourful, it's good fun, and it works. And again, like they were saying about your place value, 10, 20, 30, 40. What can you tell me about 40? What's in 40? All of a sudden, 40 isn't just a 4. It is 4 10s because they've had a very physical, a very concrete experience of handling 4 10s for 40, not just 40s. This thing in my head that I've got to try and keep a pin on. Oh yeah, there's a 4 in it. Okay, it's really good for place value as well. So in the same way, for instance, they might be asked with Numicon, again using concrete purposes, to double 5, and literally, if they know double means 2 lots of, get your 5s out, double 5, okay, double 5. Okay, so that's their answer. Or, as they're taught in Numicon from quite early on, see how it fits together. Okay, what's double 5? Well, they could simply count, or they could see what fits over it. Double 5. Let me get what I think double 5 might be 8. Let's see if it fits. Oh, it's a bit more than 8, isn't it? What else could it be then? Could it be 9? Oh no, because 9's got one on the top. No. Let's try. Ah, I wonder. Could it be 10? If it's over. It's a bit awkward to do holding it up like this. Obviously on the table it'd be easy for your children, but they begin to see double 5 is 10. And once they practice that a few times, the permanence of numbers, they'll know double 5 is 10. Okay. 7 plus 7, then in a similar way, they get their 7 piece. 7 plus 7. Again, once they get to odd and even numbers, they can see there's nothing sticking out the top. 7 plus 7, let's cover it over. Oh, well, 10's my biggest piece, so what am I going to do now? 7 plus 7 is 10 and something else, but what is that something else? Have a look at it, try something different. I think it might be 6 more. I'm going to get a 6 piece out. Am I right? Oh no, too much. Let's try a small. Oh, what about a 4? Yeah, so 7 and 7 is 10 and 4. 1 10 and 4 1s. 14. Okay, can you see how all these things are beginning to tie together? All these things start working together. The place value, because they've been taught what a 10 is, it really helps. Sum of 2 plus 2, sorry, 2 and 2. So again, they get their 2's out. 2 and 2. Again, there's nothing wrong with the concept of counting the circles, and a lot of children will do that to start with. Yeah, 2 pieces got 2 circles. That's how it works. But they'll also learn to match them up. They'll learn what colour each piece is. They'll learn what each piece looks like. Going back to what we were watching with those grids, they'll learn it, and the facts will be in their head, and then they'll be able to refer to them. They'll learn their number bonds. They'll learn what doubles are, and that's brilliant because once it's in there, they can use it. Okay, but they need to know why they need it and why they're using it. There's a couple more on there for you to go with yourselves. Numbercon's are quite expensive, and I wouldn't advise that you go out and buy your own sets because you can pay quite a lot of money for it. However, again, one of the resources I'll send you will be you can just literally cut out your own paper versions of Numicon, so they'll all fit over the top of each other, and you can use it in a similar way. Won't last as long, but you can use the concept and you can have play with your children, okay, whether they use it in their schools or not. Okay, so that's the end of part 1. Now would be a good spot for you to pause and take a break if you want to, and then come back and we'll carry on with the second half. Okay, thank you. Okay then, so welcome back, moving on. Going into doubling then as adding, because doubling is adding, the number's getting bigger, we're adding, okay? So the early learning goal for this is that they solve problems including doubling, halving and sharing, okay? We'll think about the doubling at the moment. So in year 1, the expectation is by the end of year 1, children will be able to do doubles to 20. Okay, both ways, adding and subtracting, just to make you aware. So doubles and halving. Okay, so by the end of year 1, they'd be expected to know that double 9 is 18, double 10 is 20. Okay, and again, once they've got them, they've got it, but it's getting the concept as well, which is where some of this other equipment comes in really nicely. A nice idea for a doubling game. And we'll send you this out, a plain net for dice this time, and you can write your numbers on. You can get wipeable dice, blank dice that you can literally just write them with a whiteboard marker. They're quite nice as well. But get your children to write it on for the doubling. And you could just have a go at rolling a number. 4, what's double 4? You know, if they're not sure, get your arrays out, get your fake Numicon out, work it out together, okay? And it's a permanent. Okay, so it was double 4 was 8 then, and you roll for him, what's double 4? Oh, think about it. We know this because the numbers don't change. It's permanent. What's double 4? 8. You know, get going like that one. Okay, so here's a nice game for you as well. Pet's doubling practice. So, sorry, Pete's doubling practice. What you need. So for this one, you have dice. You have some different tokens. One player rolls a dice. They double that number and cover one of the cuts of the token. So this is going back to the dice we've just made. So if you roll a 4, what's double 4? It's 8. So you cover an 8 with one of your counters. Next player's turn. If one player rolls the same as you can get rid of their counter and put yours on top. Once a player's got 2 tokens, anyone in cat, they've won that cat, no more bumping off. And the objective is to have the most cats with tokens by the end. You can moderate it to your own game. Just have 5 turns each. Who's got the highest number? You could add up your numbers at the end. Okay. A nice doubling game then. Again, making it fun. I sent you a link to some, I sent you the resources for some number lines, but just again to show you can get different types. Generally with the younger children, when they first come into nursery reception, you might have the ones like at the bottom with the cars and the patterns and things on. They tend to simplify them as they move up through school because again, it's less about attracting them to it and more about them knowing what they've got and what they need it for. One on the screen goes to 10, mine goes up to 20. Again, this one's a wipeable one, so if your child was practicing counting on and counting back, actually you can rub it out. Wipe it off. So there's some nice different number lines. Again, it's the concrete and the pictorial before your children are able to do this in their heads, so useful. So when we're using a number line for addition, we start with the largest number. Any idea why? So for instance, the one in front of us, 3 add 6. You'd teach your child to switch it round to 6 add 3. Any idea why? Okay, 2 reasons really. For a start off, if we start on the 6 and we're adding on 3 and we're going to do our counting along, there's less chance of making a mistake if we're going 1, 2, 3. We're not going as far. There's less opportunity for making a mistake. However, the other reason being, when they move on to doing this mentally, again, so once they're finished with the number lines and they start to do all this in their head, they've got to count on, if they start on the larger number, that's already in their head, 6. Count on 3 more. So initially it'll be with fingers probably. 7, 8, 9. It's just easier. Okay, so starting with the bigger number, we know the number. Once we get the permanents of numbers, we put that in our head and we count on. It just makes it easier. There's less room for error, really. It makes it easier. And also children can quickly learn, like taking that one, we've said start with the largest number. We've switched it round, it's still going to be the same answer. So again, it's teaching children that permanence of numbers and how we can do different calculations with the same numbers. So a number line for addition, counting on. Okay, so 3 plus 2. We started on 3, then we did 2 jumps. And this is the way it's explained to children at this age. You start on 3, do 2 jumps, 1, 2. Okay. Initially, a lot of children will count the number they start on. 1, 2, they'll get to 4 and they won't know why it's wrong. And if you set them a page of additions, they'll all be the same because that's where they started. Okay. This is where those track games, like the ones we sent out last week, things like snakes and ladders and those sorts of board games really pay off, because if you think about it, when you roll a dice in snakes and ladders, you don't count the one you're on, you count the next one. And this is all really good practice for when we come to number lines. You're already on it, you don't need to count it again, you move on. Okay, and that's part of the reason why we really encourage those games. Okay, so 5 plus 4, we move on a little bit from the very early stages of our pictorial and we start thinking about, okay, so now we're a bit more independent with it. 5 is the biggest number. 5 plus 1, 2, 3, 4, end up at 9. Okay, so again, started with the largest number, counted on 4 spaces, ended up with 9. And once children are able to do that reliably, as in don't count the 5, you're already on it, they can start doing that with bigger numbers and with 100 squares as well. Okay, and then it's teaching them they don't necessarily need that, they can use the skills and the memories that they've built up to some extent as well. It's confidence. Another nice way of doing this is with the Lego game. Will also be sent to you. So you start with 5 bricks each and take it in turns to roll a dice and move forward along this track according to the number you roll. When a player lands on the stage with instructions, they gain or lose bricks. They win 2 bricks, lose 3 bricks. And you get to the end. When all players have finished, the player with the most bricks wins. Okay, and you can obviously literally play this with your own bricks and whatever you're left with. Perhaps you could build something with it. Child's got a favourite colour, you could have certain colour bricks. Just another nice way of hooking the kids in. Another track game. So if you play this sort of game at the same time as they're learning about using number lines, it just reinforces it and it's good fun. Okay, we touched on this a little bit already. It's the importance of children knowing number facts. Okay, so like we were just saying, it's being able to transfer it. So 4 add 3 is the same as 3 add 4. Okay, and it's relating that. Okay, when we build into subtraction, 4 add 3 equals 7, 3 add 4 equals 7. But that then allows us to do 7 subtract 4 equals 3 and 7 subtract 3 equals 4. Okay, we start looking at those numbers. We start with objects again. So you'd have 7 of something, you take 4 away, what's left? You'd have 3 of something, you'd add the 4. You'd never change the number you start with when you were showing these relationships. So in this one, it would always be 7 until the children were secure in it. And it's being able to see how numbers relate to each other. And again, that's really important for everyday problem solving and securing this early maths. A nice game, a dice game. You roll the dice and you come up with sums that gives you that number as a total. Again, if you've got a blank dice, you could have numbers to 10, numbers to 20 as your child progresses. You could just do 6. Yeah. So, oh, I rolled a 6. Okay. Well, I know if I've got 6, I'm going to say 1 add 5 equals 6. You can write them down. You can just say them. You could write them for your child. Real simple game. A nice spinner game here. So literally, you make the spinner. You print this off. You make the spinner. So all you really need is a paper clip or something. You put a pencil in the middle and whizzle it round, whatever it lands on. So spin the spinner and cover a pair of numbers with that total. So this isn't for your very, very small children. This is for your children as they start to emerge a bit more with this. So if I spin a 4 a pair of numbers. So any two numbers that make 4. So I might cover on my grid 3 and 1. Oops, that's what I get for touching the board. I might cover 3 and 1. Then the other player has their grid, they spin and do the same thing, and the winner is the person who's covered the most numbers. Okay, so you might have 5 turns each. You might keep going to the grids of 4. Again, just a nice way of playing with numbers. And again, it's this really important that we need to get children to enjoy it. Okay, it's important to embed what we're doing, but not by you sit there and you do this, but by making it fun, making it relate to their everyday life, making it relatable to them and enjoyable to them. And all these games and things, they're still learning. It's not just fun stuff. It's fun stuff that teaches them, and because it's fun, they're more likely to be engaged with it. They're more likely to want to go after school. You're more likely to get some results from them, and it's all embedding and practicing those really important early skills, which will help them with trickier concepts as they move through school. Here's a list of some of the websites for you to have a look at. I'll make sure that's sent out to you as well. But those links have got some good stuff on them for you to have a good look around. So thinking about this week, we have covered examples of games that you can use for adding, 10 frames and the Numicon, different resources and vocabulary used in school, some of the year group expectations, and there's been some nice games, links and activities for you as well. So again, thinking back to those diary pages that we would have in face-to-face lessons, I just want you to reflect for a moment, where would you put yourself now? So think about the edition that we've covered so far. Do you feel you've moved, your colours changed at all? Do you feel like you understand more of it? Do you feel like you're really not confident still and you'd like some more help? Have a little think, see where your colours change. Just again for your own note, or if you do want to share and you want some more information, just have a think. Do you know a bit more? Are you feeling a bit more confident in having a go at this? Okay. And remember, those resources are there for you. Try and use them. Try to see what your children like. You know, if there's something that's a bit beyond them, don't worry. Try something else for now. Do a simple track game with them. You move their counters, you help them count. Just get them using numbers a bit more. Another thing for reflection, how has today's session been helpful? What have you learned? What didn't you know before? What are you a bit more confident with? And anything you'd like more help with? My email's there if you'd like it. Just an example, quite a few activities this week for you to have a go at home. We've got the 10 frame you can have a go with, spinner game, the dice game, Lego game, and all those online links. Have a go with the 10 frame, the first clip I showed you, with your children or your partner or your mum or your friend. See if you can do it. Yeah, give it a go. See how your brain reacts, because it kind of does it without you trying too hard sometimes, I think. Okay, moving on to next week then. It's going to primarily look at addition for older children, so we'll be looking at, as the children move through generally year 2 a little bit further up, understanding how it's taught in school, some of the extra things that we might use. More activities for you to get your teeth into and have a go with at home and enjoy, and some more online links. Okay, that's it for this week. Thank you for attending. I hope you found it useful and you've got some more ideas. I'll make sure the resources are sent out to you as well, so you can have a go at some of those things at home. Thank you for attending. Have a super rest of your week. Thank you.